Hello, today we'll be looking at how to form an equation of a polynomial given specific information. We will look at how to extract what we need from graphs, and then we will go into a few examples of working with an equation with different pieces of information. As always, we will look at a few tips for guidance through the problem, and then we will work out a couple problems with the understanding we have. We will look at the factored form of an equation, which is what we have here, versus our standard equation for a polynomial, which we know to be ax to the n plus bx to the n minus 1, and that continues down. We do know that when moving into graphing and finding information about the polynomial, we can extract a lot more information, for example, the y or x intercept, by the factor form. So that's why we're going to be working with this today. And the factor form essentially states you have your a, which is your leading coefficient, multiplied by x minus a c value raised to some power, multiplied by x minus c raised to some power, and that continues. And that should look very similar to other polynomials that we factored previously. I will link a couple videos in the description below if you need help on factoring. But with polynomials and factoring, we know there's a possibility to get some factor a multiple times, or a multiplicity, which is raised to a power greater than 1, which is what we have shown here. There are three general rules or patterns that can be said when trying to identify the multiplicity. So in the first rule we have here, if you have x to an odd power that is not equal to 1, you'll get a graph that resembles this shape. And so that says that if it's odd, the sign will change as x increases and it will cross the x-axis. This is true for x to the third, x to the fifth. They all have some resemblance of this graph here. And as x increases, so it goes from left to right, then we're going to cross over that x-axis and we're going to start increasing, and the sign changes. Similarly, if we are looking at an even function, so we have x minus c raised to some value, so x squared, x to the fourth, you're going to get a function that resembles a graph similar to this, what we have here. And we know that the sign never changes as x increases from left to right, and it does not cross the x-axis. Again, if you mirror x squared, x to the fourth, x to the sixth, they all resemble something similar to what we have here, the yellow being the negative and the black being the positive. And then lastly, if you have a power of 1, then you'll get a graph that crosses the x-axis. And you can think of y equals x, for example, and it crosses without any curvature as almost a straight line. And so then you'll know that you'll have a multiplicity of 1 here. Before we get into problems, it's important to note that many problems will have the statement, find an equation with a minimal degree. This is because when determining what the equation is, you may not be 100% exact. In that, if you have, like we just recently talked about, x squared versus x to the fourth, they behave the same. However, there is a difference between the two graphs, as x squared looks more like this and x to the fourth looks more like this. However, what we will be doing today will provide, if not the exact equation of the graph, one that is very similar to it. Okay, now that we understand the patterns of graphs, let's take a look at a few examples. Okay, looking at our first question, we have this graph, and the question asks us to find a factor form with a minimum degree. Again, looking at the factor form, we're going to use y equals a times x minus c1 raised to some power, multiplied by x minus c2 raised to some power, and we're going to continue that. We know when working with polynomials that when you get a factor, that is going to be your x-intercept. We see when we looked at this graph, we have three x-intercepts, which means we're going to have three factors. We have an intercept at -2, so we know x plus 2 is a factor. We have an intercept at 1, so that's going to be x minus 1. And we have an x-intercept at 3. We're going to get x minus 3. Now what we need to identify are our powers here up top. And we can identify those with the patterns that we just looked at. If x does not cross the x-axis, then we know that it's going to be an even degree. And with that, we're going to use the minimum degree, and so we're going to choose a 2. Because we could choose 4, we could choose 6, however, we're trying to find the minimum degree. So that's why we're going to choose 2 there. Next, we look at the x minus 1. We see that it does cross, and it changes signs, so it crosses the x-axis, and it changes signs. And we also see that we have a slope right here. We have a slope, and it just doesn't cross in a straight line. And because of that, we know that it's going to be an odd function, not equal to 1. With our minimum degree, we're going to choose 3 because we don't want to choose 5 or 7. We could, however, with the minimum degree, we're going to choose the lowest number we possibly can. It can't be 1, so it has to be 3. And then lastly, we look at our last intercept, which is x minus 3 here, and we see that it is a straight line and crosses with no slopes or slants and crosses, and therefore we know that we can select 1 as that multiplicity. We have to remember in our factor form that we need to keep the a out in front, and we have our function f of x. When we write this out, we have f of x equals a by x plus 2 raised to the second power multiplied by x minus 1 raised to the third power multiplied by x minus 3 raised to the first power, or we have it right there. And with this answer right here, when we multiply these together, that's going to be x squared multiplied by x to the third. So you add those together, it's x to the fifth. And then we have this last x here, which brings this total degree of this polynomial to a 6th degree polynomial. And that satisfies A. Now for B, it asks, assume the leading coefficient of A is 1, find the y-intercept. We're trying to find this point right here, and we can do that by substituting 1 in for A. In the y-intercept, all we need to do is we need to set x equal to 0, and that's going to show where the graph intercepts with the y-axis. And so if we do f of 0, we know that a is assumed to be 1 multiplied by 0 plus 2 squared multiplied by 0 minus 1 cubed multiplied by 0 minus 3. We simplify this. We're going to get 1 multiplied by 4, and negative 1 multiplied by itself 3 times is negative 1, and then we get negative 3. When we further simplify, we get f of 0 equals 1 times 4 is 4, times negative 1 is negative 4, times negative 3, which is 12. We know that this point here, where it intercepts, is 0, 12. And this is our answer for part B. So you see, this problem is relatively simple if we can understand what the patterns are from graphs that we've used many times before, as well as understanding what information the factors provide us, which, as we all know, is the x-intercept. With that information, we're able to find an equation that is representative of the graph and will allow us to, if necessary, identify further bits of information. Okay, let's look at another example. All right, looking at our next example, we're going to use a graph and it says to find a polynomial in part A, and we are going to assume in this case using the minimum degree. And then in part B, it says if A is equal to 1, what is the y-intercept? Similar to last problem, what we need to do, and it's very simple, is to identify our x-intercepts. From our x-intercepts, we'll be able to identify what factors we have, and then we just need to identify the multiplicity of each. From there, we write it out in factored form, and that is going to complete part A. So let's do that. We see that there are 3 intercepts here. We have one here, and one here, and you will have to excuse my graph because it is not super pretty. However, it does get the point across. But with those 3 intercepts, we have an x-intercept at 0, -3, we have an x-intercept at 0, -1, and we have an x-intercept at 0, 2. When we write these in factored form, it's going to be x plus 3, we have x plus 1, and then we have x minus 2. We still need to put our coefficient out in front, and this is a function of x. Next, what we need to do is identify the multiplicity of each. So we need to understand what the exponent is of each of our intercepts. Looking at our first point, we have a graph that is very similar to this, which we know means that it's an odd function that's not 1. As x increases, the graph crosses the line. So as x increases, the graph crosses the x-axis, and that's what we have here. And so with our minimum degree, we're going to select 3. It could be 5, it could be 7, we don't know, but again, at a minimum degree, we're going to select 3 because we can't use 1. That's what we're going to put here as our first multiplicity. We look at the next one and we have a graph that looks like it's just crossing the x-axis. There's no slope like we saw previously. And we know it's not an even function because it does cross the x-axis, which leaves this at a value of 1. Next, we look at the next section of the graph, which is our 0, 2, or our x minus 2 point. We see that it has a graph that is similar to an even function. It does not cross the x-axis, and it doesn't change sign. So we're using our minimum value. We're going to choose 2. And that completes our multiplicity. If we write this out a little bit more pretty, we have x plus 3 raised to the third multiplied by x plus 1 raised to the first, which is nothing, and then x minus 2 squared. And this is our polynomial with leading coefficient a at our minimum degree. And this shows that we have 3, 4, 5, that this is also a 6th degree polynomial. Looking at B, it says again, assume that a is 1, and then what is the y-intercept? For the y-intercept, we just need to set y equal to 0, or in this case, we need to make all of our x values equal to 0, and that's going to show where that intercepts with the y-axis, as well as we need to make a equal to 1. So at f of 0, we get 1 multiplied by 0 plus 3 cubed multiplied by 0 plus 1, and then multiplied by 0 minus 2 raised to the second power. To simplify, we get 1 multiplied 3 cubed is 27, multiplied by 1, multiplied by -2 squared, which is 4. Further simplifying, we essentially get 27 times 4, which is 108. That would show that this point, even though it doesn't look like it, this point here is at the point 0, 108. All we're doing is taking information that we already know, the x-intercepts, which are just when you set your factors equal to 0, and then from there we're looking at the shape of the graph, determining the power or the multiplicity, putting them all together in an equation, and then based off of the a value or the leading coefficient or whatever information the problem gives you, solving for what they ask for. All right, let's look at one more example. All right, in our last problem, part A gives us information and we're trying to find a polynomial. And then part B, we're going to sketch the graph of that polynomial. We are given 3 pieces of information. We know that the total polynomial degree is a 6th degree polynomial. We have zeros at 0 and 3, and each of them have a multiplicity of 3. If we want to write that out now, using our factor form, we can write f of x equals, we have a at 0, then we know that that's just x, and then we have a 0 at 3, so x minus 3, and they both have a multiplicity of 3. That's what that tells us there. Next, we know that if x is 2, then our value is going to be negative 24. From there, what we're able to solve for is our a value, because we don't know that yet. If we plug in f of 2, then we're going to get a 2 cubed is 8, multiplied by 2 minus 3, which is negative 1. Negative 1 cubed is negative 1. Then we get f of 2 is equal to a multiplied by negative 8, and we know that this is equal to a negative 24. If that's equal to a negative 24, then a is equal to 3. Therefore, our polynomial is going to be f of x equals 3x cubed multiplied by x minus 3 cubed. All we need to do now is simplify. When we simplify, then we can write this out. We have 3x cubed multiplied by x minus 3, x minus 3, x minus 3, and do x minus 3 multiplied by x minus 3. That's going to give us x squared minus 6x plus 9. And we still have the x minus 3 here, and the 3x cubed out in front. When we do this multiplication, we're going to get our 3x cubed still left out in front. We get our x cubed minus 6x squared plus 9x minus 3x squared plus 18x minus 27. When we combine like terms, we're going to be left with the 3x cubed out in front. We get our x cubed, gives us a minus 9x squared. And then we have the 9x plus the 18x, which is going to give us 27x. And then we are left with negative 27. So 3x cubed multiplied by x cubed is going to give us our 3x to the 6, which matches that 6th degree polynomial what we have up there. And then we have a negative 9x squared multiplied by 3x cubed is going to give us 27 x to the 5th. And then 3x cubed multiplied by 27x is going to give us a positive 81 x to the 4th. And then 3x cubed minus 27 is going to give us 81, a negative 81 x cubed. This is equal to our function f of x, and this is our final answer and our polynomial. That satisfies a degree of 6, zeros at 0 and 3, with each of them having a multiplicity of 3, and when f of x has a value of 2 for x, it comes out to negative 24. And this function of x, 3x to the 6th minus 27x to the 5th plus 81x to the 4th minus 81x cubed is the polynomial that satisfies all of that. Now, looking at part B, we're going to take this polynomial and actually go back to our factored form because that is going to help us when trying to sketch the graph. Again, we know that we have zeros at 0 and 3. So if we sketch out this graph, we have zeros at 0 and 1, 2, 3. Okay. Next, what we know is that 0 has a multiplicity of 3, and we also know that 3 has a multiplicity of 3. And so 0 with the multiplicity of 3, with the rules and patterns, we know that if we have an odd function that is not 1, we're going to get a graph that looks like this. And if it's an even function, we know we're going to get a graph that looks like this. If it's just a multiplicity of 1, then we know we're going to get a graph that just crosses the x-axis. With 0 having a multiplicity of 3, we know that it's going to cross the x-axis, and you're going to have this little slope. And then we also know at 3, it's going to cross the x-axis, and it's going to have this slope, and then that's going to continue up. That's going to continue up. All we need to do is connect these lines. Now, with the information, we don't know how far this goes down. However, this is going to be the basic shape of this polynomial, and this is our correct answer. If they ask for the lowest peak value here, you can easily solve for that. However, in this question, they just asked us to find the polynomial and then sketch the graph that meets that polynomial. And that's what we did, and that satisfies both part A and part B. And there you go. Now you understand how to form an equation of a polynomial given specific information, and or looking at a graph and how to extract the information from that graph to give us a polynomial that represents all that information. If you have any questions or comments, please leave them below. If you learned something, please give this video a thumbs up and subscribe, and we'll see you next time.